Every year, on almost the same day, a black-browed albatross returns to the exact same rock on the Falkland Islands. It's just flown tens of thousands of kilometers across the South Atlantic. Alone, all winter, and there its partner is waiting, the same one it chose 10 years ago. Sometimes 20. This is the picture we've all been handed as proof that eternal love exists. Total loyalty, never straying. But in 2017, when the sea warmed by just a few degrees, nearly 1 in 12 of those pairs split up. So if even the most faithful species on the planet can divorce, here's the real question. What does mating for life actually mean for an animal? We grew up on the same set of images, swans gliding side by side for decades, emperor penguins standing together through a blizzard, a wolf that never leaves its mate. In our heads, monogamy in animals means total fidelity, no cheating, no one else. But that was before DNA testing existed. Starting in the 1980s, when scientists began sequencing chicks' genes to figure out who the real father was, they stumbled onto something that overturned a century of assumptions. Not in a few odd species. In most of them. Around 76% of bird species labeled socially monogamous, meaning they live together, build the nest together, raise the young together, turned out to have at least one chick that wasn't related to the male feeding it every single day. Only 14% of songbird species worldwide are actually genetically faithful, staying together for life, and only sleeping with one partner. To nature, apparently, those are two completely different things. And here's the part that should make you look at yourself, not the animals. We treat sexual fidelity as proof of love, as the non-negotiable condition for a relationship to count as real. But maybe humans are the ones who invented that strange rule. Nature is simpler than that. It just never bundled those two things together in the first place. So what actually keeps two animals bonded for a lifetime if not fidelity? For more than 40 years, science had one answer packed into a single word. Oxytocin, the love hormone. Prairie voles, small rodents that pair for life, a rare habit in a family of animals famous for sleeping around, became the go-to species for studying this. Block the oxytocin and the bond falls apart. The conclusion seemed airtight. Then, in 2023, everything got turned upside down. Devanan Manoli at UC San Francisco, working with Nirav Shah at Stanford, did something nobody had managed before. Using CRISPR gene editing, they created prairie voles that never had a functioning oxytocin receptor. Not once, from the moment they were embryos. Their hypothesis: no receptor, no bond. The result was the opposite. Those voles paired up anyway, chose one partner, rejected the rest, raised pups together, same as any other vole. The patterns were indistinguishable, Manoli said. No oxytocin. And love, if we can even call it that, still showed up. Around the same time, on the other side of the planet, a different story was unfolding with the same albatrosses from the opening. Francesco Ventura, a researcher at the University of Lisbon, tracked 15,500 albatross pairs over 15 years on the Falkland Islands. He found that as sea surface temperatures rose, divorce rates rose with them, even among pairs that had successfully raised chicks before. Not because they'd failed at breeding, but because, in Ventura's theory, stress made the females misread their partner's performance as somehow lacking. And then there's one exception worth naming, the mute swan. Across every genetic study ever run, not a single cygnet has ever turned out to belong to someone other than the resident male. Not 90% faithful, not 76, zero infidelity as far as anyone's found. 3 pieces of the puzzle, 3 different answers, and none of them quite fits with the others. Which raises a question I can't quite shake. If oxytocin isn't the mechanism, and fidelity bends under something as unglamorous as water temperature, then whatever we're calling animal love clearly isn't. One single thing, happening the same way across species. It's not a switch. It's closer to a handful of different solutions that all just happen to look the same from the outside. But wait. If it's not the hormone, and fidelity depends partly on ocean temperature, is what we call animal love just a survival strategy, dressed up to look like feeling? This is where things get one layer more complicated. At the Max Planck Institute for Ornithology, Emmy Schlicht and Bart Kempenaers spent years studying a small bird called the blue tit. To a human eye, males and females look almost identical, but under ultraviolet light the birds themselves can actually see, the male is strikingly more colorful. And here's the part worth sitting with. In 1 out of every 2 blue tit nests, at least one chick isn't related to the male feeding it, 1 in 2. Not a rare exception, closer to a coin flip. So why does that male stick around? Still hunting caterpillars, still feeding the chicks, still defending the nest for offspring that, in purely biological terms, don't carry a drop of his DNA half the time. There are two ways to read this. 1. The male simply doesn't know, he's just following instinct, with no way to tell the difference. 2, and this is the part that divides scientists the most, maybe staying and caring has already come loose from the question of whose genes are actually in there. Bonding isn't always something signed into a genetic contract. Sometimes it's just something the animal chooses to keep doing, over and over, every single morning. Kempenaers and his team looked for a clean answer to why this keeps happening across so many faithful species, and never quite landed on one. That's the uncomfortable part of this research. It doesn't resolve into a tidy rule. It just keeps showing the same pattern. Staying and belonging turn out to be looser, messier things than fidelity alone can explain. In January of 1995, 8 gray wolves stepped out of metal crates onto frozen ground in northern Yellowstone. The first time wolves had set foot there in 70 years. Among them were Wolf 9 and Wolf 10. By April, Wolf 9 gave birth to the first wild-born litter Yellowstone had seen in 7 decades. Just days later, Wolf 10 was shot dead, illegally, right outside the park boundary. Wolf 9 had no one to hunt with, no one to guard the den while she went looking for food. Biologists on the Yellowstone Wolf Project worried that if she was left alone, the pups would freeze before spring ended. So they did something that had never been done. They brought her and the litter back into captivity so she could raise them without having to hunt on her own. That decision came down to a handful of days. A few weeks earlier or later, and there's no litter, no Wolf 9 raising them alone, none of the packs that followed. The entire reintroduction, in some sense, balanced on how fast someone could act after one bullet. Years later, a different pack lived out a version of the same story, from a different angle. Wolves 925 and 926 were an alpha pair. When a rival pack closed in, ready to attack pups too young to defend themselves, 925 sprinted downhill, pulling the entire rival pack after him, away from his mate and his young. They caught him. They tore him apart. 925 died in a way that everyone who'd tracked this pack for years called heroic. And 926, after getting the pups to safety, went back to the exact spot where 925 had fallen. Not to hunt. Not for any reason survival could explain. She just went there, stood for a while, then walked back to the den. No one knows exactly what she was doing in that moment. There's one more story, smaller, less well known. The Sawtooth Pack in Idaho had a female named Motaki, not an alpha, just an omega, the lowest rank in the pack. When a mountain lion killed her, the entire pack changed. They stopped playing, stopped howling together the way they always had. Instead, one by one, they howled alone, slow, mournful notes. It took 6 weeks before that pack howled together again. 6 weeks for a wolf that wasn't anyone's mate, wasn't anyone's alpha, to be mourned by the pack she belonged to. So, back to where we started. Do animals fall in love for life? Maybe that's the wrong question to begin with. Falling in love for life sounds like a fixed state, something you either have from the start or you don't, and it just stays that way forever. But not every albatross stays. Not every blue tit is genetically faithful. Even oxytocin, the thing we once thought was the whole story, turns out not to be required at all. Staying, in the end, was never a vow signed once and filed away. It's 926 walking back to where 925 fell, with no one making her do it. It's a male blue tit, still bringing food, even though half the chicks in that nest don't share his genes. It's a pack of wolves, howling alone for 6 weeks, for an omega who wasn't anyone's mate at all. Maybe some of this sounds familiar, because bonding was never a decision made once and finished. It's something you choose again, every day, even when nothing is forcing you to, even after the reason for staying has already stopped making sense. Tomorrow, choose again.